Let's now take what we've learned about loops and translate the Factr method into an equivalent loop. So the question is, how are we going to do this? Well, there's a mechanical translation that we can follow that will always guarantee a correct loop. Now the question is, how exactly do we do that? Well, the first step will be to copy the header for the driver of our tail recursive method. So we do that, add the braces, and then we change the name from Factr to fact loop. Alright, now we should add our Java doc and our test at this point, but for the purposes of this video we're only going to care about translating the Factr method into a loop rather than following the entire design recipe. Alright, so what's next? So that was sort of step one. So the second step is to take all of the accumulators that we have and convert those into local variables. So we've seen local variables before, and those are just things like variables that are declared inside the body of a method. So we're going to take the accumulator that we pass to the Factr helper method. We can reuse the same name. In fact, we probably should reuse the same name. So let's do int acc equals 1. Okay? So the mechanical process we could do is just copy this and then type an equals and then copy the starting value and put it there. Okay? So that's step 2. Step 3 is writing the following keywords. We have while, and then we're going to put some parentheses. So this is where we put the predicate. Now the predicate, as you remember, is the condition under which the loop will be true. So what we want to do is take our base case condition, which is n is equal to 0. So we're going to paste that here. We're going to add an exclamation point to the outside of that, and then we're going to wrap this whole thing in parentheses again. So what is this saying? This is saying that while it is not true that n is equal to 0, do what's inside the loop. So why this makes sense, we'll come back to momentarily. Now we want to do something where we take the parameters that we assign in the recursive call and convert those into what we call assignment update statements. So assignment update statements are just where we take the name of the argument or the parameter, do equals, and then we put something to the right. And the same thing for ACC. Okay? Now the question is, what do we put here? Well, again, this is a mechanical decision. So we just take the thing that we assign to n, which is n minus 1, paste it here, and then we take our accumulator and do that. Okay? Now we return what we call the atomic value. So this is where we return the base case value. So in our tail recursive method, we will return ACC, and that's what we're going to do up here. So just return ACC. Okay? So now let's actually write some tests. So we can take our tail recursive tests, copy and paste them, change it to test fact loop, change this to fact loop, and run it, and it should work, right? No, it does not work. So the issue is actually, let's omit this test, because really this one's the one I want to show off. So first of all, this says it expects 120 and the actual was 0. So what happened here? Well, let's think about this. So actually, let's use the debugger. So let's debug this test, and let's see what happened. So for some reason that somewhere along here ACC is being assigned to 0, and then that's being returned, and that's not good. So let's see what's going on here. So while we're in the loop, while this condition is true, we're going to decrement n by 1, then we're going to multiply ACC by n. So as you can see, with each what we call iteration of the loop, and an iteration is just one traversal, one cycle, so to speak, through the loop, we keep decrementing n by 1 and accumulating the accumulator. Okay? So now, as you can see, n is now 0, but we're going to multiply n by we're going to multiply the accumulator by 0. Okay? So now ACC is 0 and we return 0. So that's not good. Now why exactly did this happen? This happened because we updated n before we updated our accumulator. Now, when we're writing the tail recursive method, it doesn't actually matter what order we place these in. So, for example, if we had int ACC, int n as the parameters, then we could pass an n times ACC, comma n minus 1, and it wouldn't matter. That's just how recursion in general works, because there's no assignment going on. It's just what you pass to the next recursive invocation. But here, we're actually mutating variables. And that's problematic because when we mutate n, that's going to affect ACC. So, what do? Well, there's another mechanical decision we can make here. So, this is what I call the rule of update. So, what happens here is we look at all of our parameters that are being updated here. So we see that n is being updated and we see ACC is being updated. So we make a decision. Do any of these parameters use another parameter in the argument or in the expression? So, for example, does n, when we update n, does it use ACC in its expression? No, it does not. When we update ACC, does ACC use n in its expression? Yes, it does. So, because of that, we need to update this expression before we update n. Okay? So all that means here is that we move this ACC assignment to above the n decrement. Okay? And let's uncomment this out. We'll rerun it. And all of our tests pass.